Good name, Shankar. So today we are going to have a look at what is called as a model laundering. Okay. Now, laundering, the term is actually inherited from the money laundering. Okay. Money laundering is where you have the money in your bank account, but I'm not able to trace the roots of that particular amount that you have actually got. But what is model laundering? Okay. Model laundering, it is a digital piracy, okay, that is happening in the AI. Okay, so the AI world, we have this term called as a model laundering, wherein there is a model that is available, and the hacker is going to create a smaller version or the compressed version of the particular model. Now, this might sound very similar to what is called as the transfer learning. The transfer learning, the objective is not to compress the model. No, why should we compress the model? Okay, we can compress the model to get a small language model for the large language model. Obviously, there are some cost benefits associated with it, and there's a superior performance, and you can have an data privacy, and all these things are there as a part of the small language model. Okay. Now, and if I'm a hacker, what I can actually do is I can look out for a very popular model, and I can create a small language model, okay, from the method what is called as a knowledge distillation, okay, and then I can sell it. Okay, I can add a vulnerability as a part of it. Okay, I can tweak the model so that we cannot. You'll find that okay, it's not the same as the large language model. It's like I steal a recipe of a beverage, or I steal a recipe of any of the food. Okay, then I can tweak the recipe. I'll start serving it to you, and I'll claim that this is my recipe. Okay, the same, the example, okay, will hold good for the knowledge distillation, okay, or the money laundering attack. Okay. Now there are two types in which the knowledge distillation attack actually happens, or knowledge distillation actually happens. One is called the white box knowledge distillation, and another one is called the black box knowledge distillation. The black box, the white box, okay, these are the terms that are not something which are very new to the artificial intelligence. Right from the days of ethical hacking or penetration testing, I cannot say ethical hacking. I think hacking cannot be ethical anyway. Right from the days of penetration testing, we use these terms. Okay, so white box penetration testing, where I know the complete details about the target. In the black box penetration testing, where I don't know anything about the target. In between these two, there's something called the gray box. Okay. So in case of knowledge distillation also, there's something called as a white box knowledge distillation. The other one is called the black box knowledge distillation. So obviously, the white box knowledge distillation, I know the internal, I have the internal access, the internal weights and the bias of the model. How can I actually have it? Okay. This could happen with an insider attack. Okay, there's a disgruntled employee or an insider attack. Okay, in cybersecurity, there's something called a collusion attack, where there's an external hacker, okay, who's going to sponsor this attack. There's an insider, okay, the internal accomplice of who is actually going to execute this particular attack. Okay, so this is a white box knowledge distillation. In the black box knowledge distillation, I actually do not know how what is there as internal architecture or internal structure of the model. Then how can I replicate it? Okay, so we usually do it with what is called as a creating a surrogate model. Okay, how can I create a surrogate model? I'll have a shell script which will continuously send the prompts, okay, to the model and get the responses. Okay, let's say 2,000, 3,000 prompts per second. Okay, that 3,000 prompts per second. That means 18,000 prompts per minute. Okay, and then multiplied by 60 for hours. Okay, it need not be 3,000. It can be 100,000 prompts per second also. Okay. In this case, the prompt and the response from the LLM, okay, is collected, and it'll act as a data set for me to create a new surrogate model. Okay, so this way I can also do a surrogate model. I can exactly pass on what is required and get it. I can have this particular model. Now, to thwart this particular attack, white box knowledge distillation, identification, authentication, authorization. So you secure it so that it is default to deny. Okay, so zero trust. All these things, okay, as a part of the identity and access management, all the principles are there, and we need to implement that to secure our model, okay, from the internal attack. Okay. Now, in a white box attack, okay, when the model gets serialized into a file and deserialized, somebody can steal that serialized file also and then tweak it, okay, and then deserialize it. Okay, so that could also be a possibility of a model theft that will also lead after stealing the model also the knowledge distillation can be done. Okay, now how can we prevent the black box knowledge distillation from forming a smarter, the small language model, okay, which could be money laundering, sorry, model laundering attack. Okay, Now, in this case of in case of an black box knowledge distillation, what I can actually do is see I can, even if I'm going to block the incoming IP, okay, the source IP from where they're launching this attack, they can spoof the source IP. Okay, in fact, there's a tool called HPing3 on Kali Linux. Okay, you can randomize the source. So the incoming attack, okay, so it's still a technical possibility. I can randomize the source and do an prompt injection so that blocking one particular source IP is not possible. It's not going to be beneficial. Okay? Even if an IP identifier, IP ID is going to be fetched to identify the spoofed IP address, still there are mechanisms in which the IP ID can be modified. Okay? So the only way that you can thwart an attack, okay, where people can bombard you with a lot of prompts with spoofed IP address also, you can limit the number of queries that can be executed for a particular user. Okay, like you can give an API. So you can say that per month you can execute only 1,000 prompts or 2,000 prompts. Okay, so there could be commercial limit for this. So you can limit it this way that what this zero, sorry, black box black box knowledge distillation attack. Okay, so the knowledge distillation will lead to what is called as a model laundering. Okay, now in addition to blocking, in addition to the query limit, what we can still do is we can have the cryptographic lineage tracking. Okay, there's a video that I have put in last week on cryptographic lineage tracking. So the model, once it's generated, the model will have the data set and the algorithms hash, data set hash. Okay, will also be included the part of the hash that is calculated for the model. So you can trace, okay, with the cryptographic signature, you can actually trace, okay, from where did this complete supply chain for the model generation. Same can be used, okay, for the model that has been laundered. Okay, so it's an piracy. You have somebody has the counterfeit model that is available in the market. Okay, these are the scenarios. And if you are not going to look at the supply chain, source of authentication or legitimacy of using a model, that might lead to a financial suite. Okay, but a lot of, if you look at the cases, you just Google the data that's been poisoned or the data lineage problems, and the Federal Trade Commission, okay, where there had been where the model disgorgement has been forced. Okay, the FTC has forced the organization to go for retraining the model on a different data set. Okay, now though that doesn't, so we are not speaking about that perspective. We are not saying that okay, your data set is something that you need to prove. But I'm saying the model itself, you need to prove the legitimacy for actually using it. Okay, and the worst to the worst. Okay, if you're going to have an vulnerability, or if you're going to have a hidden backdoor as a part of the model, then it could be a trigger. You ask the user is going to prompt something, it'll open up a backdoor. It could lead to a disclosure. Okay, so before we deploy a model, okay, from untrusted source, or the source that you're, even the trusted source, I would actually say, but that might not be a very strong argument. If you're going to buy a model from a new source or untrusted source, it is the deployer's responsibility to ensure that the model is devoid of vulnerability for your safety, and model is legitimately created or legitimately developed by the producer. Okay, so that you can buy it. Okay, it is not sourced from a third party. Deployers' responsibility to ensure, okay, the model or what sort of applications that you're going to use for your production, you have a legal right to use it, and you need to ensure that it is not pirated. Okay, it is nobody's responsibility. Clearly, the European Union AI Act is saying for the high risk application, it is the responsibility of the deployer to verify everything. Okay, not the producer, not the provider. The deployer to verify everything. As a user, as a deployer, it is your responsibility to ensure that the model that you're actually using is a legitimate source and it is not pirated. Okay. So this is Subramaniam Shankaran. Thanks for joining me for this video. Subscribe to my channel for more and more videos on cybersecurity, data protection, and artificial intelligence. Cheers. Bye-bye.